Assalamualaikum and greetings. My name is Mohammad bin Ismail from Aqil 23. My metric number is 1910910227. I will present the introduction and background study parts in our assignment. The title of the assignment that has been assigned from us is Wave Power Generations. Okay, let's start the presentation. In developing countries like Malaysia, the demand for electricity supply for domestic and industrial use is increasing every year. Up until today, renewable energies such as solar, biomass, and hydro energy are the approaches that used in Malaysia for power generation, and it was still far behind other countries which have started to use wave power generations. The potential to implement wave power generation in Malaysia is high because the country's topography is surrounded by the ocean, and also there are so many places that can be used for the engineering research center. Wave energy is created by the ocean wave, and the capture of that energy can make us to do the functional works. For example, this renewable energy is useful for water desalination and electricity generation. The technology machine that can act as a wave power is known as a wave energy converter (WEC). WEC is a tool that converts the kinetic and potential energy through the power of the ocean wave into electrical and mechanical energy. The types of the WEC technology that can be seen at the right side in the slide is alternators, oscillating wave source converter, and also rotating mass device. We go to the next part, which is background study. The first research regarding the use of energy from ocean wave was in the year 1799, and it was conducted by Girard and his son in Paris. On the coast of his native France, him and his son invented a simple buoy attached to a lever. The idea was that the buoy would move up and down with the wave, in turning moving the lever, which could be translated into mechanical energy to power the many pumps and mills fueling the first industrial revolution. An application of wave power was built around the year 1910 by Bocquet for electricity use in his house in France. It was the first oscillating water column to generate electricity from sea wave. The oil crisis at year 1973 was a turning point for the industry. That is when the experts started looking for alternative energy sources and reconcentrated the ocean. It took until the year 1990s for actual research and development to start. In the figure in the slide, we can see the developer for each type of the WEC. For example, the first one is alternator was developed by Flamis. The second one is oscillating wave source converter that developed by Aquamarine Power, and so on. Okay, we go to the next slide. However, the development of the wave energy generation seems to have succeeded after the European Marine Energy Center (EMEC) set up the world's first marine energy test facility in the year 2003. EMEC's wave test facility is situated on the western edge of the Orkney mainland in an area with one of the highest wave energy potential in Europe. The exposed close sea location means the Iceland group is subjected to the powerful dynamic forces of the North Atlantic Ocean, with the highest wave recorded by EMEC reaching over 18 meters. Construction of the wave test facility was completed in October 2003, and the operational activities commenced shortly thereafter. It is the only accredited test center for marine renewable energy that is suitable for testing a number of wave and tidal energy devices simultaneously. EMEC has hosted 19 wave and tidal energy clients with 30 different marine energy devices that originating from 10 countries. It is also targeting other areas with a huge wave that are not connected to a grid or have a less than ideal distributed energy system, like in the countries such as Indonesia, Chile, and also the Philippines. Okay, that's all from me in my parts, and thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Muhammad Nasir, and my matrix number is 19109125. In my part, I will explain about the theory behind the wave power conversion. The ocean waves are only formed by water surface oscillation, which is a daily natural phenomenon. Theoretically, wind blowing over the surface of seawater generates waves most of the time, but they can also occur due to atmospheric pressure and gravitational fascination. In addition, natural disasters such as volcanic eruption and the movement of tectonic plates under the earth can also be related to the formation of large-scale ocean waves, like the tsunami which hit the Fukushima in March 2011 and Aceh in December 2004. There are some properties of the wave we should know since it can come in different forms. Velocity, speed of the wave that are moving past the fixed point. Wavelength, the range between one peak to the next peak. Peak, the top point of the wave. Through, the bottom point of the wave. Frequency is the number of waves that pass through the fixed point per second. Period, time taken for one wave to pass a fixed point. Height, difference between the peak and the through. There are various methods and technology involving wave power generation have been installed commercially since 2000, either from floating on the ocean surface, underwater depth, or at the coast. Generally, three main methods are used to convert wave energy into electrical energy, which are floating system, oscillating water column device, and tapered channel. For the first, buoys or floating system used in most common technology to drive the hydraulic pumps by relying on the rise and fall of the swell wave. The pump will flex and bend as the wave passes through, producing kinetic energy in the wave energy converter to be converted into electrical energy. Secondly, an oscillation water column device is a cylinder where a large amount of moving water acts as piston. When the wave rises, the air is forced out of the chamber through the turbine, which, while being sucked in when the wave falls back down, the repeated air motion in and out will drive the turbine to generate electrical power. Moreover, the movement of wave creates a condition where the air pressure constantly changes, thus changing the water level in the chamber back and forth. The last one is the tapered channel or tap can. It is a device which is quite similar to hydroelectric in terms of power conversion, except in its wave. When the wave from the sea enters the tapered channel, the wave width decreases. Then the wave amplitude and the pressure will increase according to the conservation of energy, allowing the wave to travel up a ramp and enter a large reservoir, which was built a bit higher than the sea level. Due to gravitational force, the water collected in the reservoir will eventually flow back into the ocean through a standard hydroelectric turbine, which will convert kinetic energy to electrical energy. Here is the overall conversion of energy through all the previous three methods mentioned. The hydraulic pump or turbine from the previous technology are used to produce kinetic energy with the aid of wave energy. The mechanical energy then can be further converted into electrical energy through the linear generator. Next, the rectifier will be used to convert the generated alternating current AC into the direct current DC. Then, the DC is converted back to AC using an inverter to produce an AC output, which can be controlled easily. After that, the transformer can be used to reduce the power loss during the transmission to the power grid by step up the voltage. Otherwise, a step down transformer will be used to decrease the voltage to safety level for the household electricity. Okay, that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Aqil bin Mohammad Effendi. My matric number is 1910909993, and my part is I will be explain about the mathematical model and the conclusion. Okay, first thing first, we will start with the mathematical model. Okay, a regular wave ocean can be generated regular surface wave if the wind velocity is constant throughout a wide area for a long time. Assuming wave to be two-dimensional, direction of wave propagation adds together with time can be used to represent wave elevation. Thus, the regular wave surface elevation can be expressed in a sinusoidal function of xt equal to h2 cos bracket t minus kx, where h over 2 is the wave amplitude, is the angular frequency, k equals to 2 over is the wave number in the wavelength. A regular wave, the ocean wave, are irregular and always have different amplitude and frequency. There are two crucial properties called significance wave height Hs and energy period Te. Hs is calculated from the average value of the highest wanted height of incoming wave, while T is the period from regular wave that carry the same energy as irregular wave. The elevation of an irregular wave is expressed as a sum of waves that come in different shapes of. In the equation you can see in the slide, where m is the number of added wave altogether and is the amplitude of wave, and n is the phase shift of the nth wave, which takes down value from 0 to 2. On the other hand, the angular frequency and the energy period Te and the significant wave height is Hs, influenced by the geographic location of the chosen sea state. SO called energy density spectrum, which measures the amount of energy transferred in the wave per wave angular frequency, is used to mathematically define a sea state. The spectrum is influenced by Hs and Te.
Assalamualaikum and good day. My name is Nur Aiman Syafiq bin Rastam Fendi, metric number 1910910774. I would like to explain my part in discussion part, and my partner for this discussion part is Mohammad badruzzaman bin Ali. So for our wave power generation, we choose Chile for our chosen country because it has the largest wave energy potential based on the British engineering firm Bain and Associates. So according to a executive, the Chile's coast will supply about 24% for the summer and 26% for the winter in the Chile's country. So next I will talk about the energy mix in Chile. So this pie chart that I will show you in the slide is based on the energy mix in Chile based on the 2017. Next, I will talk about the comparison between the three types of wave power generation, which is the first one, point absorber, the second one, surface following attenuator, and the third one, oscillating water column. The first one, point absorber, we choose Agucadora wave farm as our chosen one, and it is located in Agucadora, Portugal. It is a company, the company that create this farm is Pelamis Wave Power, and the total power generated is 2.25 megawatt. So next I will show you the system operation of Agucadora wave farm. Then this is the Agucadora wave farm system operation that I show you in this slide. Pelamis is the name of the machine that was used when the wave ran down the structure. The connection portions of the Pelamis machine flex and bend in each other and this motion was resisted by the hydraulic ramps, which would pump the high pressure oil through the hydraulic motors, which would then drive the electrical generators. Next, surface following antennator. The chosen station for this wave power generation is Azura, and it is located in Marine Corps Base, Hawaii. And the company that created this farm is DHL and Enway. And the total power generated for this station is 4.5 megawatt. Next, I will show you the system operation for the Azura station in this slide. Next, Azura station make use of the floating surface technology that absorbs energy from wave coming from all directions, and the generator was powered by high pressure hydraulic system. The wave motion is captured by the floating mechanisms circular rotation, which is then transferred to the Azura's crankshaft. This crankshaft provided motion for the high pressure hydraulic system. Next, oscillating water column. We choose Motrico Breakwater Wave Plant as our chosen station, and it is located in Motrico, Spain. So the company for this station is Ente Vasco de la Energia, which short form as EV, and the total power generated is 296 kilowatt. Next, I will show you the system operation for the Motrico Breakwater Wave Plant in this slide. Seawater enters the breakwater facility air chambers through the front aperture. When the water enters the chamber, the air inside is compressed and pushed out the top aperture at high pressure. The turbine, which is attached to the generator, is turned by the high pressure air, which produces energy. The air is decompressed when the water recedes, which causes the turbine to turn again. The turbine never comes into touch with the seawater, only the flow air generates electricity. This feature extends the equipment's life significantly. That's all from me. I will pass my presentation to Mohammad Badruzzaman bin Ali. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Badruzzaman bin Ali and I'm from aqil 23. My metric number is 19109104. So today I would like to present for my part, which is advantage, disadvantage and environmental impact of wave energy. So the first one, advantage of the wave energy. First, eco-friendly. Wave energy is 100% clean energy sources, meaning it emits no harmful greenhouse gases into the atmosphere. Compared to the fossil fuel, it contributes significantly to environmental pollution. The second one is highly predictable. The pattern of the waves arrive is well known. They arrive at all hours of the day and night, storing more energy than renewable energy sources such as wind and sun. On the other hand, unpredictably variable. Wind speed drop unexpectedly, so will affect electricity generation. The last one, renewable energy. Wave energy is a renewable energy, which means limitless. It does not require human intervention to survive. No one has dared to say that the ocean and the sea will vanish at some point in future. So wave energy is a dependent and efficient energy source. For the disadvantages of wave power generation, the first one, damage to the sea life ecosystem. Offshore wave energy projects are far more complex than onshore wave energy facilities. Shallow seas are ideal breeding and resting places for the most marine species from an ecological standpoint. As a result, activity related to the building and operation of the wave energy plant have a significant impact on a marine ecosystem. The second one, environmental concern. Although wave energy is a clean energy source, the noise generated by the plant generator may be too much for some local to handle. The plant also detract from ocean and natural beauty. However, in most cases, the noise created by the generator is balanced by the noise produced by the wave. And the last one, disadvantage of location. Wave energy benefit individual and community living near ocean and sea. Wave energy supply is limited to ocean and sea. It cannot be relied upon to service an entire country population. This means that cities and countries that are not near such body of water will miss out on the benefit of wave energy. So that's all the disadvantages of wave energy. Okay, for the last one, the environmental impact of wave energy. Wave energy is seen as a non-polluting renewable energy source, while wave energy system may not emit any of pollutant emission associated with burning fossil fuel to generate power, such as carbon dioxide and nitrogen oxide. However, the local area's environmental impact of wave energy also can be addressed. The first one, coastal erosion. Due to the change in current and wave, onshore and nearshore development may have an impact of coastal erosion. Tidal velocities, wave amplitude, and water flow may all be affected by the area size. The second one, device construction. Anchoring these devices may have an impact during installation. Piling concrete block, anchor and chain are used to secure a tidal many wave energy devices to the ocean floor. Dredging and scoring of the seabed may be required for the site preparation in order to install electrical cable. The number of devices installed and the mooring system used will determine the amount of ocean bottom disturbance. The third one, fishing industry. A solution zone around offshore device may influence local fishing ground. Anchor line, tether and power cable limit the usage of the net, whilst the floating devices can create shelter area that benefit some marine species and habitat by restricting access and fishing at the site. However, like marine reserve, fishing activity might expand right beyond the installation perimeter. The last one, noise pollution. The continual noise pollution from the wave capture device, particularly in pure weather. Many influence will endorphin that harm via echolocation. The operational noise level is shoreline and near shore device may be a nuisance. Locally on the beach and shoreline, when a fully operational, any device generated noise will most likely to be drawn out by the natural noise of the wind and the wave. So that's all for my part. Thank you.
So the next I will talk about the conclusion. Wave energy is a type of renewable energy that may be harvested and used to generate electricity. Wave energy are capable of absorbing much more energy than solar and wind power per square foot, and they do so considering less cost to the environment. It is an alternative to non-renewable energy sources such as coal and petroleum, which can create sufficient electricity. We are capable of harnessing 140 to 750 terawatt hours of electricity per year from the oceans using today's technologies, and this estimate is only what is economical, feasibility and profitability. Electricity is extremely important to humans because practically all applications rely on it. Electricity demand will rise in the future of the human population growth, with 75% of the world population projected to live within 40 miles of the coast. By 2025, the ocean is the most feasibility and accessibility energy sources we have. Energy resources will be greatly deeply and population will worse, while wind and geothermal and solar system of energy source can be obtained naturally. And that is for me. Thank you.